this is way too much. And deep learning and the training of these networks can tolerate significantly lower precisions. Not all computational workloads can tolerate low precision. So for example, if we go back to the data sheet, you'll see that actually these GPUs support up to FP64. And this is quite useful, I understand, for a lot of scientific computing applications. And there they really need this, but we don't need that much precision for deep learning training. So currently we are here, FP32. And with this code as it is right now, we expect to get at most 19.5 teraflops of performance. That means we're doing 19.5 trillion operations, floating point operations. So this is floating point multiply, add, most likely. And so these are the floating point operations. Now notice that if we are willing to go down in precision, so TF32 is a lower precision format we're going to see in a second, you can actually get an 8x improvement here. And if you're willing to go down to float 16 or bfloat 16, you can actually get times 16x performance, all the way to 312 teraflops. You see here that NVIDIA likes to cite numbers that have an asterisk here. This asterisk says with sparsity, but we are not going to be using sparsity in our code, and I don't know that this is very widely used in the industry right now, so most people look at this number here without sparsity. And you'll notice that we could get even more here, but this is int 8, and int 8 is used for inference, not for training, because int 8 has it basically has uniform spacing, and we actually require a float so that we get a better match to the normal distributions that occur during training of neural networks, where both activations and weights are distributed as a normal distribution, and so floating points are really important to match that representation. So we're not typically using int 8 for training, but we are using it for inference. And if we bring down precision, we can get a lot more teraflops out of the tensor cores available in the GPUs. We'll talk about that in a second. But in addition to that,